Hi there. As you already know, we modeled our data model from a conceptual point of view, which is the top-down approach. Now, for the second ingredient, we need to understand how all the operational source systems are configured. For that, we need to get the technical metadata. In this demo, I'll show you how VaultSpeed Core automates the transformation of telecom source systems in a Snowflake landing zone into a governed data vault model. We will walk through source harvest and the source editor, where raw metadata becomes a structured data vault design in just minutes. We first start by creating and selecting a new project, here the Telco Snow project. Before harvesting the sources, we validate the system parameters. Two important ones here are the object names case sensitive, which is set to uppercase for Snowflake, and for Databricks, this would typically be the lowercase. Another important parameter is the use FMC parameter. This needs to be enabled, only then the orchestration scripts will be generated. These settings ensure generated code aligns with the target platform standards. A small tip is to use our AI assistant, the Speeder Agent, to clarify your queries related to setup, configurations, and much more. We next configure the connectivity. We create a database link which connects VaultSpeed to Snowflake landing zone via the VaultSpeed Agent. Once the DB link is created, we define our sources, in this case the ERP and the CRM. These represent telecom operational systems such as customer data, subscriptions, billing, orders, usage records that are already landed in Snowflake. We now open each source and retrieve the physical objects. We click the Get Objects, open the taskbar, and wait for the task to get executed. Now that it is done, we refresh the metadata and select only the tables relevant for our data model. In the case of the ERP source, this includes all the objects. We can also configure the excludes if certain objects should not be modeled. We could also remove technical prefixes like the ERP underscore using remove object name patterns. This keeps our business model clean and domain focused. Once the objects are selected, we create a source release. This harvests and versions the metadata from Snowflake. Each release represents a controlled snapshot of the source structure, enabling traceability and governance. We open the latest release and move into the source editor. This is where automation meets modeling intelligence. VaultSpeed automatically proposes the hubs, links, and satellites. From here, we can define business keys, confirm or adjust foreign keys, assign relationships, configure the CDC behavior, choose satellite types, or modify object properties. For example, subscription captures the lifecycle details, product becomes a hub, invoice line is configured as a many-to-many link and satellite, payment is configured as a non-historized link with payment ID as unique identifier. Tax rate is a reference table now. Next thing is to save the source model. All Data Vault 2.0 rules are embedded. VaultSpeed translates business modeling decisions directly to deployable data vault structures. By default, hubs are multi-master, meaning multiple sources can feed the same business concept. If needed, we can configure specific hubs as single master. We can also perform satellite splitting. For example, splitting subscription attributes into service attributes and term attributes. This prevents wide, cluttered satellites and improves maintainability and performance. Once the source modeling is finalized, we lock the release. This ensures that the metadata is versioned and ready to be reused. Similarly, we perform these necessary steps for all our sources. Now we have a conceptual top-down view, and in this step we added the bottom-up, the technical view. In the next step, we will bring those two together in the data vault model by combining these source releases to generate a data vault model, followed by a business vault logic, code generation, and orchestration, all fully automated by VaultSpeed.